This video, we are going to discuss bidirectional search techniques. So, uh, we are going to discuss all the important points about bidirectional search technique. So, we'll start with first of all bidirectional search. It is an extension to breadth first search and depth first search, and it is a special kind of technique. Why it is special? Because two simultaneous search from initial to goal and backward from goal to initial, and it is stopping when 2 minutes generally, what we do if I use breadth first search technique. Let's say I have this graph. I have this graph. If I choose breadth search technique, let's say I have this graph. In graph, 1 is my starting node, 9 is my goal node. Now, obviously, if we want to search goal node, then without heuristics of if we talk about in uninformed search, then we generally use depth first search or base first search. So base first search generally works the way we have already discussed, and uh, uh, I have given a video already about the BFS. Um, already BFS. So depth first search, or if we see breadth first search, then breadth first search level by level. In this way, it covers the node. And if we talk about the depth first search, then how does depth first search work? It goes completely one on one side, depth one side, and when it does not find any node from there, it will backtrack. Then it finds out the next path. So we search our goal node in this way. But what is the meaning of bidirectional search? We are searching from the both the direction. What is the meaning of the both the direction? That I have started in my searching from here from one, I can go to three or four. I can go either using breadth first search or depth first search, but simultaneously I have started my search technique from goal node also, and here I am going from goal node. From goal node, I am coming towards one. That means you are going forward from starting, and from here you are doing backward search. So there is a simple example. If you tell your friend that come, let's meet. One option is that you go at his home, or he can come at your home. So this is the normal technique. Otherwise, what is one more method, that what is the meaning of bidirectional? Just say a simple example. You start a journey from your house, tell your friend also to start the journey on the same time. Then you both will meet at a midpoint. So this is a simple search. That is why bidirectional method is here, because we are searching in both the directional. Now, which is the first important point over here? That is time complexity. If we see time complexity of BFS or DFS, as we have already discussed, that is order of B to the power D, where B is the branching factor. Branching factor means how many nodes are there ahead, and D means depth, till how much depth you are going. And if we talk about space complexity also, then obviously how many number of nodes are being generated. So that much only space complexity will be there. So if over here we talk in bidirectional, then see how such complexity is going in bidirectional. You started from one, let's say from 1 you went to 2, you went to 2, from 2 you went to 4, in the same time 9 you went to 8, from 8 you went to 6. So when you have reached at 4 and 6, then from 4 you went to 5, and from 6 you reach at 5. That means what you did at this point, you both have a fixed meeting over here. That means when you started searching from here, then you searching went from here till here. And when you started searching from here, then let's say it went from here till here. So obviously, how much time complexity will you find out over here? How will you find the time complexity? So obviously, how will the time complexity be calculated order of b to the power d if you do not talk about order? If we see it generally, then how much will be the time complexity? Maybe it b to the power d by 2. Why? When you are going forward, then you are going forward. Then you can say that half path you are going till half depth, obviously, till half depth. Obviously, first you are going till full depth. That means you are going from 1 till 9. Now, when you are going towards forward, then you are going till half path. That means you went till 5. Then order of we, if we talk simply b to the power d by 2, where by is the where b is the branching factor. We are taking branching factor as same. So over here, if I talk about forward, then this is a formed. And if I talk about backward, then is backward also. Also, what is your depth? From 9, you came to 5. So over here, also, b to the power d by 2, that means what will be the total time complexity? The total time complexity is b to the power d by 2. Although we write generally as order of b to the power d. Okay. But obviously, if you see over here, clearly time complexity over here as compared to BFS and DFS is reduced. So next, if we talk about the space complexity, then here is no change in space complexity because you are traversing same number of nodes which you are doing in BFS and DFS. So over here, also space complexity is B to order of B to the power D. So if anyone asks you what uh, anyone ask you that why should we use a bidirectional? What is the advantage of bidirectional? Why should I use bidirectional? Then the answer is simple. Time complexity is reduced as compared to VFS and DFS. Uh, and generally, the time complexity is b to the power d by 2. But if you want to write in the form of order, if we talk in the O's case, so in O's case, it will be order of b to the power d, which is the same as BFS and DFS. Next is completeness. So next is completeness. So next is completeness. In this algorithm, complete, what is the meaning of complete? Will this always give me answer? Will this give me always an optimal answer? So obviously, it will give an optimal answer, but over here, remember this point. If you are using BFS, always then it is a complete. Obviously, it will give an answer, but if you're using DFS, then there is in the case of may or may not. Okay. Over. here there is a simple example. How does DFS work? You have already seen over the DFS search generally works on one side. If I travel from here, I will go to this, then I went to this, then I went to this. If I don't get any path ahead, then I will do the backtracking. So obviously, if you are starting from here, let's say you started searching from here, and this is your goal node. So you are searching from A to 9. Okay. So obviously, if you are starting from this to this, uh, uh, and you are going to your friend's house and your friend is coming towards your house, then you decide a point in between to meet. But in our case, if it happens that there are two parallel lanes that then what does the DFS do? Let's say we follow this path in DFS, and then I will completely go in this particular path. Okay, and after the complete that path, I will go in this path. I will go till complete that, and then if I did not find the node, then I will backtrack from left hand to right side. Okay, but this case of breadth search only if you or take case of breadth first, then BFS is generally works level by level. So if you will work level by level, if you will work breadth wise, what is the meaning of breadth? You are going here, also here, like one to two, two to three, three to four, four to five, like successive way. Okay, and there is a guarantee that you will meet at a midpoint. That's why we use BFS search technique in the bidirectional search. So that I get completeness over here, I get an optimal solution, and my time complexity as compared to BFS and DSpace, it will be less. But if you are using DFS, then in that case there is a possibility of in may or may not, but this gives guarantee solution over here in case of bidirectional search algorithm.